Hello guys and welcome back to CS with Mr. G. In today's lesson we are going to go over some Unit 7 style questions which covers the topic of algorithms and problem solving, and in this video I would like you to really focus on the marks that are available in paper 2 outside of the programming and pseudocode questions, which some students can find quite difficult, but that does not stop you from achieving a high mark in paper 2, and hopefully I can show you the gaps that you can fill with questions that can simply just be revised with things like keyword terminology and understanding certain concepts within programming without actually having to write the code for it. So even in this first question, where we are defining the term abstraction, this is showing knowledge of the program development lifecycle, which again doesn't require you to program, but should be an easy 2 marks, as abstraction simply means to simplify a problem by removing unnecessary details. You could also say selecting only important requirements, and another word you could use is filter, so to filter out irrelevant details. So abstraction and decomposition are 2 of the keywords that you go over right at the beginning of Unit 7. Decomposition means to decompose or break up, and abstraction is to focus only on the important parts. 1b, identify 3 component parts when a problem has been decomposed. So just a reminder, this all takes place during the analysis stage, which is right at the beginning of the program development lifecycle, and we have to pick out 3 things that you're looking for when you decompose a problem. So the things that we should be looking out for are the inputs that will be required in a problem, the outputs, any processes that take place within the program, but any storage. So this is where we think of our variables or anything else that needs storing. But these are the key components that we're looking for when we decompose a problem in the analysis stage of the lifecycle. Identify and describe one other stage of the program development lifecycle. So we've already spoke about the analysis stage, which leaves 3 more left. All we have to do is pick one and describe it. I will show you all 3. So the second stage is the design stage, which includes the details of the solution, e.g. pseudocode or flowchart. The third stage is to code the design or implement it. So coding/implement, and this is where we actually make the solution. And you would simply say the program is developed, and you could talk about a specific programming language if you wanted to. But in this case, just simply stating that the program is developed at this point is completely fine. And then finally, once the program is finished, we test it, and it's the testing stage, which is where we test for errors or ensure the program works correctly. So this is the program development lifecycle, guys. It was covered very early on in Unit 7, and again, these questions are often included in paper 2 and should be the easy marks that we pick up in the exam. Question 2, an algorithm has been written in pseudocode. So let me just split screen this here so we can see it properly. So pseudocode is on the right. All we have to do is state the purpose of this algorithm. So we've got 3 declaration statements at the beginning. We declare A, which looks like it's going to be an array storing 10 pieces of data of a string data type. Declare T, which is a variable, and that's a string. Then we have C and L, which again are 2 variables, and these are an integer, so 2 numbers. L is set to 10. So in line 4, L is set to 10. And in the line 5 to 8, we have a for loop, which is going to run from 1 to L, which is 10. So I'm going to replace this with 10 to make it easier to understand. And C will be the letter that represents the number as we loop through our for loop. So we go into the loop in line 6, we are asked to enter a name. And then within A, which is the array, in position C, which is currently 1, as it's the first loop, we input the name. So let's just type in name 1. This is stored in the array in position 1. So on this side where I've got some space, I'm just going to jot down what the array currently looks like. So position 1, we've stored name 1. Next C, so C is incremented into 2. So that means we're in this position in the array. Output, please enter a name. Enter it in position 2. So this time I'm going to type in a new name. So I'm just going to put name 2 to make it easy to understand. And this is stored in our array over here. And name 2 is stored. Next C, so C is now 3. And as you can imagine, guys, this is going to fill up the array, stopping at number 10. So it's literally entering 10 names. Once we have those 10 names stored, we have another loop, which again is a count-controlled for loop. C is set to 1 on the first run, and again, it's going to run to L. And if we remember, L is 10. So again, it's going to loop 10 times, but within this loop, we have another loop. So this is where it gets a bit tricky. And now we have L, which is also set to 1, but this is going to increment differently to C, as C is in the outer loop. And this one's going to run 9 times. And what it's checking is that if A, position L, so L is currently 1, so that's name 1, and it's checking if it's more than A, position L plus 1. So L plus 1 is 2. So that means it's comparing name 1 to name 2. Now, when a more than symbol is used when comparing strings, it's basically checking which one is higher than the other in the alphabet. So although this isn't a very good example of comparing alphabetical order, I've now got a suspicion that this is checking for alphabetical order which means it's going to be some kind of sorting algorithm. And once we continue, we will then be able to determine what kind of sorting algorithm it is, as we've only discussed one sorting algorithm in the GCSE course. So back to the code, line 11, is name 1 more than name 2 in the alphabet? Well, it's not in this case, but I'm just going to change these to make it easier to understand. And let's just imagine that I typed in the names Alice and Bob when I entered the names before. So what it's asking for in line 11 is that is A more than B in the alphabet? Well, in this case, it's not, because A is less than B. It becomes first in the alphabet. So this whole if statement here would be skipped, and we'd simply go to the next L. So L would now be 2, and that means we're looking in position 2 in the array, and we're going to be comparing it to L plus 1, which is 2 plus 1, so that would be 3, and that will be this position here. So let's just imagine I entered the third name, and this name was Alan. So as I loop back round, I'm now checking if A position L, which is Bob, is more than position Alan, which in this case it is, because B is higher than A in the alphabet. So I put the data from position L, which is currently Bob, into a variable called T. So I'm just going to make a note of this here. So T now contains the name Bob, and then I put in the position where Bob was, which is A position L, the one next to it, which is L plus 1. So the third position, which was Alan, now swaps over to Bob. So now Alan is stored and not Bob. But then in line 15, L plus 1, which is 3 in the array, we set to whatever T was, which we set to Bob. So Bob, if I just make a note of T down here, is put into the third position and replaces Alan, which means Bob goes there. And as you can see, the original positions of Alan and Bob have now swapped, and it's been sorted in alphabetical order. Now this loop will continue until it reaches the end of the array, and then loop again a further 10 times. At the end, we output the full array in lines 19 to 21. But hopefully, guys, you should have recognized what this algorithm was. And this is what we call a bubble sort, and is something that you are required to know. You are required to write the algorithm for it. But hopefully I've explained and I've reminded you of the bubble sort lesson. And this is simply taking in 10 names and putting them in alphabetical order and storing them in an array. Next, we have to identify 4 processes within this algorithm. So 4 things that were processed. Well, in line 4, we initialize the variable. So initialization, where we set the variable L to contain the number 10. We also use the input command. So in line 7, we input 10 names. We also, in the same line, stored these names in an array. So that again is a process by storing data in an array. We also use the output command. So in line 20, we output the names. And you could also mention that in lines 5, 9, 10, and 19, we used iteration. So we looped using a count controlled loop. So these 4 processes all took part in this algorithm. And then following on, we have to state better names for the variables and the array used in this algorithm. So the array was called A because simply A stands for array, but in a real world scenario, you would call your array something suitable. And in this case, you just call it something like names because it stored 10 names. T, C, and L were all doing a certain job. And if you are familiar with bubble sorts, then you should recognize that T was the temporary value. So the temp, where we simply stored a name for a short amount of time in order to swap our names around. So T was the temp variable. The variable C, which was used in our loops, should have been called a counter, as it was counting how many times we performed a loop. And then L would have been better off using length, as L represented the amount of names in the array, which, as we know, length is often used in programming. State 2 other ways the algorithm can be made easier to understand and maintain. So this goes back to the maintenance of programs. I'm just going to go full screen now because you don't need to see it anymore. But things that we do in programming to make it easier to understand, well, we can use comments. Commenting code always makes it easier to understand. We could have also used a procedure or a function. This makes a program modular and again makes it easier to understand. Also, the use of white space or indentation also makes it easier for us as humans, just so we can read it clearly and understand what's going on inside the if statements and all of the loops. So any 2 of these for the 2 marks. But again, even if you struggle to understand the bubble sort, this kind of question, you should be picking up marks in paper 2 as it's fairly simple to understand. Question 3. A programmer is designing an algorithm to calculate the cost of a length of rope. The program requirements are to input 2 values. This will be the length of the rope and the cost of 1 meter. We're going to perform a validation check on the length to make sure that it's between 0.5 and 6. We're going to calculate the price of the rope and then output the price rounded to 2 decimal places. Use the variable names given so price, length, and cost. I'm going to create this algorithm using a flowchart for a possible 6 marks. So first and foremost, state the name of the validation check. Well, we're looking for a number between 0.5 and 6. You should recognize this as a range check. And next, let's complete the flowchart in the space below. So first and foremost, start, we need to input the length. And what I'm going to do, I'm going to write the pseudocode equivalents in the boxes. And just a little tip, always write your commands first, as it can be tricky if you draw your shapes and then try and write inside of them. And also draw your arrows as well. Make sure there's an arrow symbol. So we input the length. Then we need to check if the length is between 0.5 and 6. So is length more than or equal to, because it was inclusive. So we need to say equal to, and length less than or equal to 6. This is a decision, so it goes in a diamond. And decisions always have 2 outputs, a yes and a no. Now we need to think, where does the no arrow go if the length is not in between these values? So if it's not, we can tell the user invalid number. This is an output, which is a parallelogram, and we go back to the beginning to input the length again. And this will keep looping until the right number is input. If it is correct, then we need to know how much the cost is per meter. So input the cost. This was the name of the variable, and input is a parallelogram. Then we need to calculate the cost, and the name of the variable in this case was price. So the price will be set to length multiplied by cost, and this is a process. So it's a square or a rectangle, and then we can output the price. And it did state to round it up. And what I'm going to do here, I'm going to use the pseudocode command to round up. And I'm going to put price is as a string. And then the round command, the variable was called price. And it's the 2 decimal places. And this is an output command, so it's a parallelogram. So this statement here will round the number to 2 decimal places. In the exam, if you forget this command of round, then you could still write an instruction like this here to pick up the marks. But basically after this, the whole thing comes to a stop, and a reminder, please never forget to put the stop, as you might lose the mark in the exam. So this is complete a flowchart. I hope that made sense. And again, 6 marks for completing this algorithm. Question C gives 2 different sets of test data for this algorithm and state the purpose of each test. Well, set 1, the number 3 could be test data, and this will be considered normal to ensure that the algorithm works as expected, or you could have stated that the number is accepted. The other type of test data you could have put is 8, and this is considered abnormal, and this would be to make sure the number is rejected, as it only allowed numbers between 0.5 and 6. The other type of test data that we haven't mentioned is extreme, and this would have been 0.5 or 6, as they should have been accepted. And you could have mentioned this one for A instead of the 2 above. So possible 4 marks, 2 for each, and test data against something else that always comes up in the exam and should be guaranteed marks for you. Question D, complete the headings for the trace table to show a dry run for this algorithm. So if a trace table was to be completed for this algorithm, we need to state what kind of things were stored and anything that was output in the algorithm. So we had 3 variables, the length, the cost, and the price. And then at the end, we would state with the outputs. So for example, if we input the length of 2, the cost of 1, the price will be 2 times 1, which equals 2. And the output will be something like cost equals 2. And then we need to describe an improvement that should be made to the requirements of this algorithm. And we could have said a further validation check on the cost variable. So validate the cost input. And you could have said again, a range check if there was a certain range. But you could also mention a presence check, as it can't be left blank, or even a type check to make sure that it's a number. Quite a difficult question to answer, but when you're asked about improving algorithms, always look to validation first. Question 4, tick 1 box to complete the sentence. Verification is used to make sure that a value entered has A, not changed during input, B is an integer, C is correct, and D is not a string. Well, B and D, fairly obviously not those. They will be types of validation. C is quite vague. How do we know if data entered is correct or not? Which leaves A, and this is a clear definition of verification to make sure data has not been changed during input. So again, make sure you're familiar with validation and verification. Make sure you know the differences and that you can explain the 5 types of validation techniques and the 2 types of verification, which are double entry and visual check. Question 5, a validation check has been used to make sure data is entered in this style. State of type of validation used. Well, let's just quickly go over them. We've already used a range check before. It's not that. A length check checks for the length of a variable, presence check, type check, and a format check. Now you could technically use a length and a presence check. As a length check, we'll need to make sure that it's 1, 2, 3, 4, 5, 6, 7, 8 characters long. However, we have to be careful because there are forward slashes involved. A presence check could also be used as it could not be left blank, for example. But I would say a format check would be the go-to answer for this question, as it has to be in a certain style, which is just another word for a format. Question B has further questioning on test data, and it says that one example of abnormal test data should be used to check that the validation is working. So state an example of a normal and an abnormal piece of test data with the reason why. So normal would be any date in this format, and as you can see, this will be accepted. Something that's not in this format, we'll just write the same date using this, and this should be rejected as this does not meet the requirements. So 2 marks for each for a possible 4 marks. And then question C goes back to the length check, which I mentioned earlier, and how it could be used. And we would need to check for 10 digits, 8 for the values plus the 2 forward slashes. And if the length is less than 10 or more than 10, it should be rejected. And in question 6, draw one line to link each pseudocode statement to the most appropriate use. We've got the pseudocode statement of call with the name color and in brackets new color, which is a variable. So call, you should recognize as using a function or a procedure, which we can see down here. Setting the value to equal a1 plus a2 plus 3 divided by 3. Well, you've got 3 values, adding them up, dividing them by 3, which clearly gives you an average value, which is there. Then we've got loop 1 set to loop 1 plus 1. So the plus 1 clearly indicates a counting technique. And then if a variable is more than 7, the variable is called count, then set the variable x1 to 0. We've only got totaling and a conditional statement left. It's clearly a conditional statement as the word if is used, which is also known as selection. And again, guys, these are the keywords that you should recognize for those marks that I keep going on about in our paper 2 exam. And then finally, a 1D array, so one-dimensional array called temperatures, has 25 elements beginning at index 1. It holds values that range between -20 and 100 inclusive. Write a pseudocode algorithm to use a single loop to find the lowest value in this array and output the result only once. You don't need to declare or populate this array, so we can assume that the array is already created and contains values. So for example, temperatures here, 20, 30, 25, 22, and so on. It starts at index 1 and it has 25 elements. So this will go up all the way to 25. So we can just imagine that there are 25 numbers inside and we are looping a certain amount of times. So that should indicate clearly a count controlled loop, which is a for loop. And we're going to loop 1 to 25 as the index starts at 1. I could have put I here instead of count, but as we're going to use this as a counter, I've called it count to make it easier to understand. And if we think back to the algorithm of finding the minimum value, we need a variable to store the minimum value. So at the beginning, I'm going to declare a variable called min, and this is going to be an integer. I'm going to set min to a value, and I'm not going to set it to 0, and I'll explain why in a minute. I'm going to set it to 100, and we'll come back to the reason why shortly. But now we go into our loop, and we're going to loop 25 times, and we need to find the smallest value. So the first thing I'm going to do, I'm going to check if in the temperatures array in position 1, which is labeled as count, okay, I'm not going to write the number 1 because the count represents 1 on the first run. I'm checking if this number, which is currently 20, is less than the min, because if it is, I'm going to set the min value to the number in that array. So as you can see, in this case, 20 here is smaller than 100. So currently, 20 is the smallest value that I've got stored, as it's the first one that I've looked at. Now, had I set 100 to 0 at the beginning, 20 is not less than 0, so 20 would not have been stored in this variable, as this if statement would not have been met. So that's why setting the min value to the biggest possible value is a crucial part of this algorithm. Likewise, if you're looking for the biggest value, you would set it to -20, because that's the smallest possible value. So just remember, the min and max values, you always start off with the opposite of what you're looking for. So I can simply end the if here. I go to the next count in my for loop, which will take me to count number 2, which is the second number in the array up here. And again, if this number is less than the current min, which it's not because 30 is not less than 20, this is skipped. We don't store it and we go to the next number until the loop is complete and we've checked all 25 numbers in the array, storing the smallest one, and then simply outputting it at the end. So the lowest temperature is, and then the name of the variable was min. So that's how we'd output it at the end. And again, guys, the minimum value algorithm, the exact same as the max, except you'd swap this round and you'd set this to the smallest possible number. So that's all we're going to cover for today, guys. There are different types of questions in the paper 2 exam, which I've not got time to cover today, but please stay tuned for paper 2 practice videos. where we will see questions such as trace table completion and more pseudocode practice, again, to make sure we can cover one of the hardest and trickiest units within the course. But as always, I hope you managed to follow along this far and you are now gaining some confidence in attempting some paper 2 past papers. So thanks for watching, guys. The documents in the video are available in the description below. Don't forget to like and subscribe if you're enjoying the course and you're managing to follow along, and drop me any questions in the comments below if you're unsure with any of the topics that we've discussed in today's lesson.